everyone, it is Mrs. Cooper. I am looking forward to being back with you guys soon, but we are going to be continuing on in our brand new notes packet. Woohoo! So we are still talking about the topic of ecology, and so we all should have received a new notes packet which has this very nice triangle on the front. If you remember, we ended last unit talking about food webs, which is how energy moves through the environment. We are still going to be talking about the movement of materials through an environment, but we are going to, instead of looking at energy, talk about matter. So to do that, we are going to be flipping to the third page in our notes packet. So let's go ahead and do that. So we'll skip over the first two pages for now. We will come back to those. But we are going to be looking at how matter moves through the environment. And so just to jog our memories, if we go to this picture, we ended talking about how energy does not have a cycle, right? It is a one-way track. We can say it moves in one direction. It goes from the sun to producers to consumers, and that is it. Instead, now we are going to be talking about how some things can be recycled, and those things are going to be matter. And we're going to talk about 4. Not today, we're just talking about 1 today, but a total of 4. We'll look at the water cycle, how water recycles. We'll look at the carbon cycle, the nitrogen, and the phosphorus cycle. So we'll just look at 1 for today, but know that we're trying to figure out a cycle. So how does matter start at one point, go through transformations, and end at that same point? Okay, so we call these cycles a very fancy term. We call them biogeochemical cycles. And if we look at all those prefixes, bio we know means life, geo could mean earth, rocks, chemical, we can think of chemicals. So it's how materials are moving through life forms, through rocks, through chemicals on earth, and how they are being recycled. So we've touched on the fact that matter, not energy, can be reused and recycled. We're going to talk about 4 biogeochemical cycles in total, just 1 today. And we're also going to see this term reservoir for each of the 4 cycles. And a reservoir is just a place where we find a lot of that material. So when we talk about the water cycle, the reservoir is going to be a location on Earth. It could be an abiotic or biotic location, where that compound is found, where we find most of it. So we can start thinking ahead of where might we find a lot of water on Earth. So as I've been saying, we're going to look at the water cycle today, and that is it. I'm hopeful that we maybe have heard of the water cycle before, but if not, we are talking about it today. So if you notice, and there's some repetition throughout the notes for each cycle, but for each cycle, we have some steps in bold, some key components. And then below it, we also have a diagram that visually shows each of those steps. And there are some arrows that we will label to show us what process is exactly happening. So we'll get started. So as we've been saying, in a cycle, it means that we are going to start at one point, go through some changes, but still end at the same point. Think of a circle, right? There's no beginning or end, it's continuous. So the idea of the water cycle is that yes, water might go through some transformations, but ultimately it just keeps getting reused. So let's say our starting point is maybe going to be the atmosphere. We're going to think that water is in the atmosphere, maybe as a gas. It's in clouds, it's a water vapor, it's as a gas. And we'll go through our first step. That is the idea of precipitation. So if we have water in the air and we want it to come onto land, we can probably think of some ways that may happen, right? We can think of it, it could rain, it could snow, it could sleet, it could hail. So that is the idea of precipitation. When water vapor that's in the atmosphere is going to condense, so it says water vapor is going to condense in the atmosphere, and all that means is it will go from a gas to a liquid as rain, or maybe a solid as snow. And so that is going to be shown, and I'm going to color this little box purple. I think yours have a unique shape, but it should be a box. But you can maybe make a little mark next to precipitation. And we're going to look to our diagram and look for some arrows that are maybe showing water going from the atmosphere to Earth. And it's looking like arrow A. I'm going to give that a quick little shade. And arrow B are showing us some good precipitation, showing us going from the atmosphere to Earth. So that was arrow, our arrows A and B. I'll write that maybe here, A and B. Okay, so now that water is on Earth, two things can happen. So the first option will be that it hits maybe some sort of rock formation on Earth, and the water is going to run off. That is when water flows off of solid land, and eventually it will move to a body of water. So that is our next one here. Maybe I'll show that in orange. And that is going to be represented by arrow E. So runoff is that the water has hit land and it maybe has flowed off of this mountain and now it is running off into a body of water. So it's moved across the landscape. But we know, of course, that that does not always happen. On a rainy day, you might look out in your backyard, and while you may see some water running off your driveway and moving over across the land into a drain that will eventually empty into a body of water, sometimes the water will just soak in, right? It'll just soak in through the soil. And when that happens, it becomes something called groundwater. When water is absorbed into the soil, and the same outcome is going to happen, that eventually it gets absorbed and it gets funneled to another body of water. So that is arrow D. It gets soaked into the land and then flows to a body of water. So those are kind of our two options. Either it hits the landscape and just flows off of it, or it could get absorbed, but eventually they'll all end up in a body of water, a lake, an ocean, a stream, anything like that. So if we remember, we said a cycle has to begin and end in the same points. So we started in the atmosphere, we had precipitation, rain, snow, sleet, or hail, had it fall onto land, it moved across the land through runoff or groundwater, but we have to find a way to return it back into the atmosphere. And that last way will be through evaporation. Evaporation is when water is going to go from the liquid state back to a gas. And so those would be arrows C and F. We can see some evaporation might be happening over land, and some evaporation might be happening over water. But it returns us back to our starting point. So that is our cycle, right? Yes, water has been transformed, but we've ended and begun in the same spot. The last component is our idea of the reservoir. Where do we find most of the water on Earth? If we're looking for water, where is the place to go? And of course, we might have been thinking about it, it would be oceans. Actually, 97% of all water on Earth is found in our oceans. So that would be the reservoir to know. That is an abiotic source. That is where we'd find most of our water. So that is us for today. I am going to post a nice screenshot of this for us on Teams as well, and we'll have a practice, but hopefully we are feeling better about our water cycle. I will see you guys later.